All right, so we were joined from University of Mississippi Medical Center by my man, Jonathan Lee, uh, researcher, lab manager, you name it. He's running things down there in the lab in the Department of Pediatrics at UMC. We thank you so much for joining us. I got a room full here with me at Velma Jackson High School. We're recording this for all of our friends in Madison County schools, Madison Central, Rosa Scott, Ridgeland High School, Germantown High School, the Academic Options Center, and our YouTube channel. And we're in the health science career cluster. And this is such a cool career because when people think about health science, they just think about doctors and nurses. But there is so much that goes into it, and you guys do such great work that really is so underlooked, and so underappreciated by so many people. But it's just so vital to healthcare. So we thank you so much for joining us today.
Glad to be here.
All right. So before we get into all the work you do there in the lab, just give us a little background on you. St. Andrews High School, then went to Baylor out in Waco, Texas, and then went to Mississippi College for a master's. So just take us through that process because you were involved in a lot in high school, extremely talented musician, involved in a lot of academics, and then that took you out to Baylor University.
Yeah, thanks. I'm born and raised here in the Jackson area. Went to high school at St. Andrews, and I did pretty well for myself. And then, I wanted to go out and see what the world had to offer. And then I applied and got accepted to Baylor University. I started off in a kind of a university scholars kind of great text course, and then I ended up changing to a biology major. Yeah, I was in high school. I was really involved in a lot of things, extracurriculars, music, church. Also, some. I think I was in uh, the quiz bowl team at school. I was also participating on like the honor council there for a little bit. So I kind of had a wide variety of interests while I was in high school, and that kind of helped me set the stage for college. After I graduated from college at Baylor, I came back because my family's still here in the area, and then I ended up getting accepted into the master's program, the biological medical sciences program, I think is what it's called, the master's there at MC. And then after I got my master's degree there, I ended up getting a job and a position here at the Department of Physiology initially at
Oh, cool.
University of Mississippi Medical Center. But over the period of the last 10 plus years, I've been in different labs, and now I'm currently in Department of Pediatrics, Division of Newborn Medicine here at UMC.
That's awesome. Now, I do want to mention real quick because that master's program of medical science and at MC is world renowned, and I think it flies under the radar. I know medical professionals literally all over the world that have gone through that program at Mississippi College, and they say I got into my program at Tufts or at Harvard or at Southern Cal because of this program at MC. So I really encourage anybody interested in anything medical science really consider Mississippi College. And I don't endorse colleges. I'm not affiliated with MC, but I just, from what I know and from what I have seen, Mississippi College is a great option for anybody interested in medical science.
I would agree. When I was in the program there, I think it had already been in existence for maybe about 4 or 5 years. So it already kind of had a little bit of fame, I guess you could say. So there were a lot of out of state students. I met people from Texas, from California, from Wisconsin that were here because they were getting that master's degree because they were trying to get into another level of professional school, such as medical school or dental school or PT or dental school. In addition to that, there is also if MC is not an option, I think UMC a couple years after that ended up creating a
That's right.
master's program of their own as well. So if you have any students that are interested in doing that or wanting to stay closer to home, these are both good options, especially if you're looking or interested in doing anything related to the medical field.
Absolutely. Now, then you said you moved into the lab after that. And I just think it's so important because, obviously when COVID happened, in 2020, we had a lot of frontline nurses and doctors, but so much of the work was being done in labs. More and more work at these hospitals is being done in the labs, and you're dealing with state of the art technology. You guys are on the front line. Doctors are the ones and nurses are the ones dealing face to face with the patients, but they got to get information from the lab. They've got to have things analyzed in the lab. They've got to see, will this work with this? I mean, I'm not a medical expert at all, but I do know a lot of work before it ever gets to the patient has to be done in the lab. So just take us through some of the things you guys do. And I know you mainly deal with pediatrics and newborns, but when we were talking last night, you were explaining some stuff, and I was like, dang, that's pretty cool.
Yeah, I mean, we do quite a bit of things. I mean, we are in the Department of Pediatrics and Neuro Medicine division, but we are kind of in the basic side of things, so basic science. So we do a lot of lab work. We call it like wet lab or bench work. So we're doing a lot of stuff with assays and doing stains and things like that using the microscope, things that you might have learned or been exposed to in your biology or chemistry lab. But like you said, Greg, that in order to get to the part where you're working with patients, where you're giving vaccines or you're giving treatments, you kind of have to start on the other side. So if you want to think
Absolutely.
of this side as being the clinical side, when we're working with humans and patients, you want to think about this side as the basic science side, when we're trying to test theories and hypothesize about our theories, right? And we got to test those. We got to create studies, and we need to examine that and do it many times. And then over the period of time, we call this like translational science. We're trying to get from bridge the gap from just doing basic science stuff, writing and doing theories and working with animals or modeling using computers to translating it to working with humans. So that's I'm kind of on this side, but we do work with a lot of clinicians like our neonatology fellows that work with the babies in the NICU. So
Absolutely.
yeah,
And
yeah,
you know,
yeah.
yeah, and that lab information is so vital. And I mentioned, I had a hospital stay last year. I had a emergency surgery, and obviously I had people working with me in patient care, but they had to send some things to the lab to make sure there wasn't more wrong for them to find out. So these people in the lab are doing a lot of important things. They're analyzing blood, they're analyzing fluids, they're analyzing anything that comes out of a body, all types of test results, and then they have to relay that information to the patient care people.
Right. Now, like I said before, we don't necessarily work with human samples or things like that. That requires another kind of level of clearance and yes. But we do work with treatments, and like you mentioned before, we do test different theories. We recently working on a treatment using insulin, which is naturally produced in humans, and then we're trying to see if
Oh,
that's an
wow.
effective treatment. So, we are testing things before we test them in humans, right? So we're trying to see if
That's
that
cool.
works because maybe eventually we can use it and implement it in the human context or in the clinical context so that we can actually, save lives or improve the outcomes for newborns and their mothers sometimes.
That's awesome. Now, if somebody is interested in getting into this, it's a field that needs more people, need more people that understand technology, need more people that can write and communicate. So, like we said, people think hospital, they just think doctor or nurse, but you guys are always needing great people to get into research with you. So, if somebody's interested in the lab side of things, what are some things that they need to know and work on now to be in this type of position?
Uh, it's a pretty good question. I mean, it's not necessarily like a one size fits all kind of thing. Research is a really, really broad field, and you can do multiple kinds of research in all kinds of backgrounds. So, like I said, like at the University of Mississippi Medical Center, there's different departments. There's like right now I'm in pediatrics, but there's also physiology, there's pharmacology, there's chemistry, there's biochem, there's psychiatry and neuroscience and things like that. So in terms of like preparation for the students, if you guys are interested, I would challenge you to just work on the sciences, right? Your math and sciences, the STEM classes, things that are like that, because that's one way you want to find out whether or not that's something that you're interested in, something that you're passionate about, because you don't know just yet if this is what you want to do, and even if you do it, you may not end up doing it for the rest of your life. So you want to just kind of take the classes, do well, and establish some good foundational study habits. Also, you want to outside of class, you want to try to reach out to if you're interested in the medical field, reach out to some doctors or some dentists, or if you're interested in vet school, you want to reach out to some of the vet clinics, see what it is that they do, do some shadowing, do some volunteering, service work like that, because that way you get the exposure to the stuff that they do on a daily basis and see what kind of work they do. Because you say, ask yourself if this is what you want to do in the future. So there are
Yep.
opportunities here to be research volunteers as high schoolers. Obviously, there are some limitations because of being under the age of 18. There are some things that you can or cannot do, or sometimes you have to be 18 or older to be able to do it. So those are certain things you have to be aware of. There are certain programs that may be available at different colleges, universities. I don't know off the top of my head if UMC has any currently, but I know for college age. So if you get into college, there are some summer programs that you can apply to that actually allow you to be in a program at some of the colleges, universities across Mississippi, not just UMC, that allow you to have this exposure and get some research and just to see if this is what you want to do. Now, research is not necessarily like a glamorous job, right? You can be a doctor, like a PhD, but it is not like say like as glamorous as being a physician. But you do good work, and there are a lot of
Absolutely.
ways that you can contribute, and there is definitely a need because it's not like I said, a money making thing, and it's pretty hard. The payoff can take years sometimes, because research sometimes doesn't happen overnight. But it is rewarding being able to, find something to write about something, to publish something, to publish the work that you've worked really hard on. It does reward creativity, does record, kind of reward people that are hardworking, people that are, self-starters. It does require a little bit of independence when it comes to doing stuff like that because it can be kind of be a lonely road sometimes. But I think if you have a passion and interest in this kind of field, and I think it would be pretty rewarding. But you have to enjoy, you have to want to do this, um, um, and do it for the right reasons, in order to make it possible, to make this career field possible for you.
Absolutely. Now, you mentioned something there, and I'm glad you did, because I know I can speak for every other teacher that will see this, because I deal with this all the time. Because you mentioned about sometimes it's a long road. Medical research is not something you're not going to figure out something overnight. There's a lot of trial and error. There's a lot of trying different things. So, how often do people in medical research get it right the first time?
uh, hmm. That's a tricky question. Pretty much, it takes many tries. Like if you have any students that are into coding or programming or anything like that, there's a lot of like trial and error. There's a lot of troubleshooting. We're testing different things. So we try this, and if it doesn't work, we adjust, right? But there's still many different things that you're adjusting. So it takes time to do that. And once you've figured something out, then you want to test another variable. We want to test a different condition. So you want to change that, and we add this. So these things take time, and we add and add and add because we want to make sure that when we get to the point where we're ready to publish or we're ready to continue to the next step, that we have everything covered, right? Because we don't want to have inadequate or incomplete research or incomplete data, because eventually the goal is to get it used or to
Yeah.
implement it in the clinical setting, right? So if we give you something that's incomplete or inaccurate, then we could end up risking or harming the lives of humans. So ultimately, our goal is to make sure that we have good data, accurate data, and complete data. Now, it's not always the case, but we try our best to get to that as close as possible. But like you said, Greg, it does take time. You have to be patient, and it doesn't always work out. The results may not always give you what you want, but you have to go back, analyze, troubleshoot, and test again.
Yeah, and the other thing I wanted to ask, because you've been in this for a while now, is we hear
Yeah.
about it all the time on the news about. I'm not trying to say you're old because I'm older than you.
Well,
On
yeah.
the news, you hear about on the news all the time about technological advancements in medicine. So, what are some technological advancements that you've seen just in your time working in this field? Because you get to deal with new technology all the time.
I mean, I personally don't, Greg. We're pretty old school, old fashioned in our lab. Because sometimes, you probably know as we get older, like you kind of figure out a way that works and you kind of stick with it. It doesn't really matter what changes because if it works, it ain't broke, don't fix this, what the old adage is, right? And sometimes it's really funny. Sometimes science is based in logic and using the scientific method, but sometimes science can be kind of a thing where people kind of they have superstitions as well. They kind of want to stick to what the tried and true methods. But in terms of like technology that I've seen, with the advent of higher processing speeds on computers and imaging has gotten a lot better, a lot quicker, and
Oh
much more
yeah.
efficient. So we do a lot of tissue work. So we work mainly in the neuroscience area because we're examining a lot of brain tissue. So we do magnification using microscopes that cost hundreds of thousands of dollars, and we are imaging stuff and trying to map out things of the brain. But some of those things are kind of old. You should imagine like back in 15, 20 years ago, the scanners we had, like the resolution's pretty crappy, right? But now they have resolution that's really, really sharp, right? And it's
Yeah.
really fast and the color high quality. They have really vibrant imaging. That's a big step in technology. Another thing is if we're implementing more and more coding, so you're using more and more programming software. Like the hot topic now is like machine learning and AI. You'll understand that there's a lot of broad applications of these kinds of tools, even in the medical field. So if you look at research, there's more and more of that being added or being used to help aid researchers and doctors to help maybe increase the accuracy of their tests and their data, and also maybe to save on the time because computers can move much more efficiently if you train them properly to kind of cover the amount of data that you need to see that might take one doctor several hours. It could probably take a computer program, maybe half or even less than that amount of time. So
Wow.
those are a couple things. So really, just the equipment we use keeps getting better and better.
That's
Then
awesome.
we work with a lot of assays, and the technology with the assays has gotten better and better. So we're able to test for different and more types of markers when it comes to testing for different issues in our tissues that we examine. So I think those are probably some of the main points. I'm sure there's more, but that's probably what I encounter most often.
Yeah, and that's and you mentioned that, biomedical engineering is really big right now. They need people to develop this new technology to develop these imaging, to be able to, to be able to fix the machine if it breaks. So, that's another great area, on the clinical side on the lab side that's really, really important. If kids are interested in this type of stuff, because developing new medical technology not only saves lives, it can make you a lot of money.
It can. I mean, I can't speak directly to it, but I do know a lot of people that even if you don't do like the academic side of things or don't go into this kind of research here, you do have the option and the ability to go into what they call like the biotech field or the industry.
Yeah.
Once you graduate with either a master's or a PhD, because people, like I said, we're working with tools, equipment, assays, and plates and kits that have to be developed, right? They have to be R&D, right? So there are companies that require student or they need people that have this background to develop, to test, and to create these things, and that can be used in labs like this one here at UMC. So that's kind of interesting because you can create new tools using the technology that we've gained over the last 20 or so years.
That's awesome. Well, I do have some questions from the students, and these are really good.
Right?
So I'll get to as many of these as I can. This first one is Levi
I
Johnson.
try
He's
my
in 10th
best.
grade. This is a good one. He asked, "What are some of the different animals you've done tests on?"
Right now, I currently work with the rat. So that most of our models are around what they call like an animal model or rat model to model certain issues or diseases that we might see in humans. So we can test that first in the rodent, and then we could maybe eventually develop something that could be used in the human. But in a previous lab, I have worked with mice as well. Now, just letting
Wow.
your students know, these are not wild animals. They're not like grabbed from the street, from the dumpster or anything like that. They're actually, born and bred specifically for laboratory use only.
Okay.
So they're not, not exposed to any kind of disease or anything like that. So they're raised in a controlled environment. But that's the model that we primarily use here in our lab.
Yeah, and you should have seen their faces when you said rat. It was a pretty good reaction. I like this one. This is Anaya Goins. She's in ninth grade, one of our power lifters here. And she asked, "What's the craziest thing you've ever seen in your research?"
Not a lot of crazy things. I mean, I want to say it's I don't want to say it's boring, but it's pretty it's kind of it's a regular 9 to 5. I mean, in terms of craziness, no, we not nothing too crazy to be honest. Like there are certain tests that we use that are can be quite interesting, quite fascinating, but nothing too crazy.
Awesome. This is Sydney Evans. He's in ninth grade, one of our baseball players here. And he asked, "What was the hardest thing for you to learn in the lab once you started the career?"
I think it's more of like maybe a mentality. So it's kind of learning and understanding that there's some things that you don't know, um, and
There you go.
to understand certain limitations that you may or may not have. And the challenge of that is just understanding that, recognizing maybe some weaknesses or some knowledge gaps that you might have, and then trying your best to bridge that gap. So if there's something that didn't go well, a test didn't go well, or something I don't understand a concept or something like that, then it's important for me to try to problem solve it, to try to troubleshoot that, to learn, and to so that either I can fix it or for the future, or at that moment, or try to use that as a basis going forward. Yeah, so I think it's more of that learning about learning is what it is. And yeah, that's I think that's
Big
probably. I
time.
mean, it's kind of a not
Yeah,
maybe a cop out,
teachers
but
always
yeah.
say, teachers always say we're lifelong learners. It's the same. It's the same principle. You aren't ever going to know everything, but learning as much as you can. So I agree. That's a great point. All right, I got time for two more. This is Ethan Cook. He's in ninth grade, one plays every sport here. But he asked, "What convinced you to get in this part of healthcare rather than the clinical side?"
Ooh, that's a tough question. I mean, there's always an itch, maybe the clinical side. I don't know. Like, I enjoy a lot of the work that I do. I mean, I do sometimes think about the clinical side. I think the way I kind of get around that is because we, are in the Department of Pediatrics, and we are in the Division of Human Medicine. So we do have interactions and communications with the medical and the clinical side. So
Absolutely.
we have research fellows, the neonatology fellows that have, finished their medical school career and residency and have, added joined the fellowship program, and then we work with them to develop some research projects for them
Oh,
to
cool.
do over the 3 years that they are here at UMC. So we're working with them. We sometimes have medical students from M1 year all the way up to M4 year that are uh, interested in doing research over the summer or during the school year. So we kind of have those options. And then the basis of our research is really geared towards uh, newborn medicine, right? So we are focused on the baby, right? We are trying to develop techniques or discover treatments to help with the medicine side of things. I enjoy a lot of what I do here. The In terms of like life, pay is probably not so good, but uh, in terms of lifestyle, it's pretty steady. I'm not on call. I don't typically work
Yep.
on any weekends. So it's a pretty set structure in terms of schedule. I kind of work independently. I do kind of work with people, but oftentimes I am kind of working solo. And I set my own schedule. I do have a supervisor, but I am kind of my own boss from a day-to-day basis. I do have a lot of responsibilities in the lab since I supervise a lot of different labs in our department. So those are opportunities for me to do that. And yeah, so in terms of clinical stuff versus basic science, I feel like this is kind of my strength. It does allow me to kind of change and
That's
do different
awesome.
things that are interesting to me. So we're oftentimes running different projects at the same time, multiple studies at the same time. So it allows you to kind of do a lot of different things. I think that's kind of interesting about that. So I think that's probably why I like it the most in terms of that. And then a little bit of exposure to clinical stuff doesn't hurt either.
Oh, I agree. I got time for one more. This is Christian Fields. He's in ninth grade, one of our football players, and he asked, "What type of degree should I focus on if I wanted to get into this field?"
There are a lot of options because, like I said, there are a lot of different departments, a lot of different kinds of research being done. You definitely want to stay somewhere in the kind of in the science or science adjacent fields to probably give you the best chance of doing well and being able to kind of understand what's going on in the lab. But I think we talked. Ideally, you want to start with maybe like a biology kind of biochem, chem, things like that. But I think we talked about it before. I think the most important thing is just like you want to come in with like a willingness to learn. Because if you come to lab, a lot of times you can be taught. Like we can teach you techniques, we can teach you skills, we can give you the knowledge base that you may not have because you come in with a certain set of knowledge or skill set, but there's certain things that you don't know about the lab or any lab that you're in. But there are people there like students or lab managers, researchers, scientists that can help you and teach you and guide you on the day to day to learn certain techniques. Because there's some things that you don't learn in school. You have to be taught in the lab and trained in the lab. So I would say you want to focus in terms of like having a knowledge base. If you're interested in neuroscience, do some neuroscience. If you're take some neuroscience classes. If you're interested in psych, do psychiatry, psychology. If you're looking in that field, like I said, if there's physiology, you want to kind of take some of those human HPhys classes, do anatomy. You want to, if you're kind of take courses that are interesting to you, that
Yeah,
you want to learn more about, because that helps a lot. If it's something that you're not interested in, you're not going to really want to work hard or learn, and you're not going to remember it either, because at the end of the day, if you're not interested in it, you're not passionate about it, you're not going to enjoy or get much out of it, and it's going to become more of a chore than anything else. So I would say, just to answer the question, try to stick with something science related, but more than anything, you want to come in with like an open mind and a desire to learn and to gain more knowledge and more skills in the lab.
absolutely. Well, we're almost out of time, and we thank you so much just for taking a few minutes for us. But before we go, just real quick, um, that's like I said, the work that's done in medical labs of any type is so important to the healthcare just for everyone. In your case, babies and the Department of Pediatrics. So if kids are interested in getting into this, why should they really consider getting into this area of healthcare?
There is a need for medical providers. There's a need for primary care healthcare providers. In the state of Mississippi, we are definitely in, in great need of that. There's a shortage of that. In terms of research, there's UMC is a great uh, research institution. It is the only one academic research institution in the state of Mississippi. So it serves a vital role in providing training for future professionals in the research, medical, and clinical fields. So nurses, doctors, dentists, and such. When it comes to research, though, we do need to kind of fill that gap because it is a tough field that does not have a lot of students. There are not a lot of people that are interested in doing getting a PhD, MD, PhD like that, or anything that's related to the research field. But we need it because we need people that are innovating. We need the next generation to train so that they can develop new drugs, new treatments, new technology that'll help the future kids, the future babies that we see in the hospitals. Because we had to start from there in order to get to the part where we work with humans. There's a lot of options to do that, but I think without that, we won't be able to develop the new techniques and procedures for the people of the state of Mississippi.
Absolutely. Well, again, we
I
thank
hope
you
that
so
answers
much
the
for
question.
joining us. Oh, we thank you so much for joining us and fitting us in your schedule. And please give your parents my best. Just such great people as well. So, again, we thank you so much for joining us there in the lab at UMC. My man, Jonathan Lee, thank you so much for joining us today.
All right, thanks for having me.
I'll see you, buddy.